Welcome back, everybody, to the final, probably, video for Computer Science Education Week 2020. This is the fourth part of a series of tutorials on using JavaScript and the Phaser game programming library to make a simple platformer game. We're going to get right into it. Let's remind ourselves what we're using. We are using Phaser as our game programming library. We're using art from Kenny. The Phaser Sandbox gives us an easy way to write and test our code without downloading anything. And if you don't currently have the code up, you can copy and paste it from this URL. So let's do that now. So we are in this URL. I will select all and copy. Delete the code that's already here and paste. And as usual, it wants to give us a couple extra spaces at the top that I don't like. So I'll delete those. And we will run our code to remind ourselves where we were yesterday. So we had our little character TM, we had some platforms, we have a diamond. And TM can pick up the diamond and it plays a sound. So let's take it from there. My goals for today are pretty simple. I want for us to add some more diamonds and add a scoring system. So let's go back to where we added the diamond. It was this line here, collectibles create, and remember we have to do this little bit of math to figure out the coordinates to line it up with our grid system, and it references the item key that we created in the preload function. So we could do another line like this with just different values for the x and y coordinates to create another diamond. But just like we saw with the platforms, if we're going to do the same thing multiple times in a slightly different way, it's a good idea to create a function to wrap up that process so we can reuse it in a smart way. So I am going to copy this code, and we're going to come down to where the extra functions go. And I'm going to create a function called makeDiamond. It's going to take two arguments, two inputs, x and y. The x and y coordinates in grid coordinates for our diamond. I'm going to just copy that code, paste that code that I copied from above, and let's see. What we have here should pretty much work. The only thing different is instead of 6 and 4, we're going to use the x and y that came from our inputs. So now makeDiamond is a function that takes two arguments and creates a diamond on the screen. So we can replace this call or this line that does it by hand with a call to our functions. Just for the first time, I'll use the same coordinates, so 6 and 4. So 6, comma 4, and with a semicolon. And if we run this, we should get exactly what we had before, but done with more elegant code. So now that we have this makeDiamond function, we can use it to create as many diamonds as we want. I'd like to maybe create a diamond on top of each platform. Now remember the way coordinates work in computer graphics. Y coordinates increase going down. So on top of or higher on the screen means a lower y coordinate. So this diamond with a y coordinate of 4 is the one that's on top of the platform with the y coordinate of 5. So if I want to make a diamond on top of this platform, it should have a y coordinate that's 1 less, or 1. Maybe I'll give it an x coordinate of 7. And then on top of this one, it should have a y coordinate of 1 less than 4, or 3. So makeDiamond, I'm going to use 0 for my x here, 3. And on top of this platform, y coordinate is 6, 1 less is 5. So makeDiamond I'm going to say 11, 5. Let's see if that looks right. Alright, so now we have diamonds all over the screen. We could certainly add more, but I think 4 will be good for right now. And because of the way we wrote our code using a group, they all have the same logic. And so even though there's only one collision handler function, it works for all the diamonds, and we can pick up all of the diamonds. Well, since we have all these diamonds now, we should let TM get some kind of reward for picking them up, which means we need to implement some kind of score system. So let's do that now. And the first part of that is going to create some text on the screen. In order to do that, it's actually pretty easy. We are going to need a variable to hold our text, and we'll create that up in our global variables area because we need it to be accessible from both the create and the update function. So I'm going to call this let score text. Alright, and then in the create function, I'm going to actually use a Phaser function to create it. So score text equals this add, so we're adding something to Phaser, text. Alright, and then the arguments to this, the first are the x and the y coordinates. We don't really need to think about our tile system for this. The score doesn't really correspond with any of the tiles on the screen. It is still measured from the upper left. I'm going to say 12 over 8 down. That's pretty reasonable. Then the next argument is the actual text. This is going to change when TM picks up a diamond, but for right now, we'll just say score colon space 0. So the score starts off at 0. And finally, there's an object describing the properties of the text. You can change things like the font size and the actual font and other things about it. So at the very least, we need to set the font size. So that's the font size property. And I'm going to say 24px. Px stands for pixel, so these will be 24 pixels high. We also need to set the color. Fill may be a weird word to use for color, but it's basically the color that it's filled in with. And it's going to be FF, FF, FF. Now, when you're specifying colors in web terms, it's often done with this little notation where there's a hashtag or a pound symbol followed by 6 characters. The first 2 refer to how much red, the second 2 to how much blue, the last 2 to how much green, and the biggest thing possible is FF. So this is lots of red, lots of blue, lots of green, which basically means white. If you have all the colors together in computer graphics, that makes white. So this will be white text. So now, if we run this, we've got text on the screen, although we have not done the code yet to make it change when TM picks up a diamond. So let's do that now. We're going to need some place to store the actual score before we can display it. We could create another global variable for that, but we've already kind of cluttered up our variables more than is really a good idea. And since the score is something that belongs to TM, let's find a way to attach the score to TM. That's easy enough because Phaser gives sprites this function, setData, which lets us set some data to be associated with the sprite. So I'm adding code to the create function right after TM was created, tm.setData. You need to give it a key, just like we've used other places, a string to distinguish this from other data we might set, and then a value. Well, the score starts at 0. Alright, then let's go down to our functions at the bottom, particularly the pickup diamond function, and we want to add a new feature to it. What we want it to do is, when a diamond is picked up, to add to TM's score. To do that, we've got TM in a variable here. TM, we're going to use another function called inc data, which allows us to actually increment the data, add to the data stored in TM. So we call that score. And so let's make it 100 points per diamond. Why not? All right, so now when TM runs into a diamond, it adds 100 to its score, it destroys the diamond, and it plays a sound. We're almost there, but we still haven't arranged to have the actual score on the screen updated yet. To do that, we need to go back to the update function. And we could do this another way, but let's do this so that every time the screen is displayed, we'll update the score. Now, most of the time it's not going to change because most of the time TM hasn't just picked up a diamond, but when it does, it will be reflected immediately. So we're going to use our variable that refers to the score, so that was score text, and then it has a property set text, which does what you think it does. And remember, the text contains not just the number of the score, but that label, score, colon, and a space. So let's type that, score, colon, space, plus, and then we'll get the score value from TM. So that's TM dot get data score. Here this plus doesn't add like you add two numbers. With strings, and score is a string, the plus operator concatenates. It puts the two strings together. So it's going to take the string of scores, colon, space, and then add the string or concatenate the string that represents the score number. And that's what we'll display on the screen. So let's see if that works. Look, score changed. As we go and collect more diamonds, the score changes more. And yay, we've got 400 points. So I want to add just one more feature today. Instead of having all the same types of diamonds, let's add multiple different types of diamonds and give each one a different score. If you'll recall, we actually have several different possible diamonds. We used the yellow one, which was item 08, but there's also a blue one, a green one, and a red one that we could have used instead, or we could use as well. Of course, to do that, we're going to have to load those each in the preload function. In the interest of time, I'm not going to make you watch me type that out 4 times. So through the magic of editing, we're going to come back and look at the preload function. I've already got the statements to preload each of those different colored diamonds here. But now I've got to figure out a way to use them, because if you recall, we actually use the key yDiamond for the yellow diamond in our makeDiamond function. So we need to somehow make it so we can select what color diamond. Also, we said we wanted to use different values, so we need to select that as well. Well, we can do that by giving our makeDiamond function some more input, some more arguments. So let's have one called key, which will be the key referring to the preloaded images that we're going to use, and then one called value, which is how much the diamond is going to be worth. So the key is easy to use. We just replace this hard-coded string yDiamond with key. What we're going to do with value is a little bit more involved, not much. We need to add another line here. And so first we need to say let diamond equal. So instead of just creating this diamond and forgetting about it, we're going to do something with it on the next line. So we need a variable to hold it. So let diamond equals, that means create this diamond and then store it in this variable so we can refer to it on the next line. And then we're going to use that set data function again to store the value along with, as part of this diamond. So I'm going to set data. I can use any key I want. I'm just going to call it value. So now, each time we create a diamond, if we pass it the correct a value, that will be stored in this value data item. Okay. Now, that means we need to make another change. Down here, where we are using the collision function to update the score, instead of always updating the score by 100, instead we want to use the number that came from the diamond value. So we're going to replace 100 with diamond get data value. All right, but now since we've changed our make diamond function, we have to change it so that where we call it up here in the create function, we pass it those extra arguments. So let's create a blue diamond. So B diamond with a value of 100. We'll create a red diamond, R diamond, with a value of 200. We'll create a green diamond, so G diamond, with a value of 300. And we'll make our yellow diamond, Y diamond, have a value of 400. So let's run it and see if that works. All right, well, the different colors worked. They're all there. The green diamond was worth 300. The blue diamond was worth 100. The yellow diamond was worth 400. Oops, bad jump there. And the red diamond should be worth 200 if I can ever get TM over there. All right, so there we have it. And that is where we're going to stop with this series of tutorials. Certainly there's a lot more we could do with this game. Right now, even though we have finished and collected all the diamonds, nothing special happened, so we could certainly add some in-game conditions. It's not a very big game world. It's possible to make it so the world scrolls. There's some issues where the collisions aren't very precise. We could fix that as well. We could add other game elements, enemies, other kinds of power-ups. All those things are possibilities, but in order to keep this to a manageable size, we're going to leave those. I'm going to leave those for you to experiment with. I've had fun doing this. I may continue, so you might want to check back on the main page for the Computer Science Education Week 2020 and see if I add any more, or check back on the YouTube channel. But if not, hopefully you have enjoyed playing along with these tutorials as much as I've enjoyed creating them, and I wish you the best of luck with your future programming endeavors.